and we will 10 o'clock. So I think if our able moderator, if he wants to start recording, we can start recording. So
Just start.
because okay, good. So we're talking about now. Last time, just to say that not being a teacher, I'm learning to revise. We talked about the chain reaction and how the Manhattan Project got named and started. And General Groves, was a tour de force. He was a giant of a man in more senses than one. He went on a blitzkrieg tour and established various laboratories all over the United States, in appropriate locations, using the power of the army. And to me, as the more I read about it, it's just mind-boggling as to when government makes up its mind, how quickly they were able to get about doing this. And I don't know if we might have addressed it as to why Los Alamos was selected, because they wanted it far from the major cities for secrecy, because they were afraid that the German spies would be infiltrating, and we'll have a lot more to say in this class about it. They wanted to be away from the international border. They wanted good weather in secrecy. And Groves, even though he was an MIT trained engineer, he did not trust all this prima donna scientists, because he had to keep all of them in line without distractions. So, and various places were assessed, some in Utah and some near New Mexico. And Oppenheimer was familiar with a boys' ranch because, being a New York kid, he had taken a vacation during his gap year to New Mexico. He fell in love with the terrain in the desert there. And so he suggested that, that this might be an appropriate place. And as we talked about as to how he turned out, even though he was a theoretical physicist, he turned out to be an exceptional choice, that he was based on national appeal and personal charm. And he was able to recruit who is who of American physics and chemistry. And that this was not just physicists alone, because as we mentioned in the first class, this was thought to be so-called physicist war, but there was much more to it than that, because just from the about 250 scientists type of thing, the workforce just went to the hundreds of thousands of people. And not just physics, but it involved metallurgy and also the military science, the ordnance work as to how to actually get the firing worked. And this was a sorted sort of bunch, because there were people who were, native-born, American-born citizens. At the same time, a large contingent was European migrants, And again, Grove, being paranoid as for the secrecy, he did not trust these foreign-born people. And especially there was some inherent prejudice against people who were Jewish, because he thought that a lot of these people could be, kind of working for the other side. And so this was, and especially the person who came up with the idea, Leo Szilard, was kind of because there was a huge controversy between the scientists who wanted open research and Groves, who actually wanted to compartmentalize all this research as to need to know basis only, because in fact, the one hand did not know what the other was doing. And the scientists, especially Leo Szilard and even the others, rebelled against it. And so much so that he went and challenged his authority to a dramatic extent. And now, again, and the good example of that is in this particular slide, that now this is why I said, okay, well, you can read the first slide. I'm not off my rocker. I'm not just talking about cosmology here for stellar nucleosynthesis, but the person named Hans Bethe, or Bethe, don't know how to pronounce it properly, but he worked on the mechanism of star formation. So that was his original research, and he was kind of a theoretical physicist. And now QED, and for those of you who are not necessarily physics majors, may not know that in this case, it doesn't stand for quadra error demonstratum that you may have. I don't know if in the United States we had to write it at the end of geometry class, but in the British system, when we proved the geometry theorem, we had to write QED, quadra error demonstratum. Okay, but as boys, we used to just say at a private school, say Queen Elizabeth died. That was our abbreviation for that. Okay, but here it stands for quantum electrodynamics, which is a major theory that was proposed, in quantum physics. So just to digress, and to prove that Groves was not totally wrong, because hence there are various divisions that were assigned at Los Alamos, and the so-called T division was theoretical division, and the two people who the one guy who actually was cantankerous and did not get along with the establishment very easily was a brilliant person who is the bottom picture. He's none other than Edward Teller, who has a but he was jealous that he was not appointed head of the T divisions, while Hans Back, who was older and more experienced, was appointed as a division. And he just was not an easy person to get along with, even though he was exceptionally brilliant. And this is interesting that most of the theoretical work, which was done with chain reaction, they had already solved the major problems. So even as early as 1943, they were moving ahead to the so-called thermonuclear bomb. And that's an abbreviation for fusion bomb, of the so-called H bomb. And Edward Teller was strongly anti-Nazi, and he wanted to build bigger and bigger weapons. And his idea was to start, so just to placate him, Oppenheimer had assigned him to work on H-bomb, or the thermonuclear division. And at the same time, he also worked on the more complicated problems in theoretical physics. But not all of them, I think. And the one person, I'm just thrilled with the personalities that are taken. And most of you that are two most famous physicists, if you ask any person, and the same would be Albert Einstein. And the other person would be well known to most people who have some interest, peripheral interest in science, would be the person on the left-hand corner, is the young Richard Feynman. And obviously, I think just to rehash, it's absolutely a delightful biography that Richard Feynman was still only a grad student, and he did not have his PhD at that time, but he was recruited to work on the theoretical divisions at Manhattan Project. He was probably barely 22 or 24, and out of Princeton. And obviously, you can do a whole class on Richard Feynman himself, because it was absolutely a colorful, larger-than-life character, to put it mildly. And at that time, he was obviously did his theoretical physics, but even at that time, he was kind of a joker, that he managed to crack safe and played bongo and was a colorful character not only at Los Alamos, but even after he got out of Army, because when he returned to Cornell, he would go to bars to pick up girls, and he would say, "Yeah, I worked on the Manhattan Project." And sure enough, yeah, sure, you did. So that's some of the colorful story. And for those of you who are interested in one of these books that is interested, surely you're joking, Mr. Feynman. That's absolutely a delightful book that you could read about. Now, moving on further, I talked about that, that the well-worn phrase that I alluded to this was a military-industrial complex, and this slide just pretty much illustrates this. I went to the trouble of trying to find all of these logos of the who is who of American industry, that some of these corporations were dragged in reluctantly because they were not interested in, working on, because this was hard work. And as I mentioned when we talked about chain reaction in Chicago, that after that, DuPont was assigned the task of building reactors at Hansford, and Union Carbide worked on some of the plants. And Mellingtrot is an isotope and atomic science giant. Monsanto did work. Alice Chalmers in Midwest as a Milwaukee-based firm that worked on the magnets that were used on the uranium separation. KBR is part of, and one of the, it's a big engineering company, which is part of Halliburton, based out of Houston. And one of their division called Kellogg Corporation worked on some of the projects as well. So you can just see that this was a gigantic effort that was taking place. And there are some spin-offs that came up from that. For example, a Teflon and closed circuit television set monitoring was used for the first time at Hansford to make sure, because they were working with pretty toxic material, i.e. plutonium. And Hanford was, not Hansford, I'm sorry, the correct word is Hanford, was still active. And obviously there was one of the first reactor that was initiated by DuPont and the Army Engineering Corps. And at the end, the Veristar had as many as 8 reactors working. And they were in operation for a number of years, even after the war. And 2/3 of the plutonium that was built for United States nuclear arsenal came from Hanford from 1944 to 1989. The rest came from a plant near Savannah. Okay, so total of 8 reactors, and we alluded to on the problem with pollution that took place. Okay, now I think just to make it interesting, I thought I would give a pictorial series of as to this was the early site of Oak Ridge, Tennessee. Okay, this was the site that was picked up because of the location in the background, and just from this wilderness and just a simple hut that went on to become one of the most secretive city. Now, at the same time, the experiments were going on at Los Alamos on the actual formation of the weapon, and the nuclear physics was going on. And they realized that there were some issues that were taking place between the two main fission material that they were working on, uranium and plutonium. Their behavior is different because plutonium had so-called detonation because it decomposed on its own, so the gun time mechanism would not work. And at this, okay, so, and this again, the entrance area of Oak Ridge and the secrecy was paramount. Okay, and now the reason why it needed collaboration of various disciplines, because the physicists were obviously clueless about the gun design, because based on just a theoretical calculation, they had calculated that a gun type mechanism that was needed to get 2 parts of the uranium-235 close to each other, would have to be extremely long. The gun would have to be almost like 30 or 40 feet wide. But at the same time, the Army people who knew a little bit more about guns than the physicists, they said, okay, well, we're going to use this weapon only one time. So the gun doesn't have to be of that strong a material. So that's one of the reasons that they were able to reduce the size of the bomb so that they could load it up in B-29 plane that was used for the main drops. So it just, again, to emphasize the point, it needed various disciplines. Okay, now this is one of the ways, even women who worked on the plant had to go through lie detector test. And this was how the recruitment went on. And again, here it shows about how the propaganda by Uncle Sam was in full swing. And at the same time, the chemists were doing their share to keep the whole project going. We mentioned about Glenn Seaborg, who was the pioneer chemist who isolated plutonium, firstly in Berkeley, and then continued his work at the Met Lab in Chicago. Now, we talked about just to refresh your memory, the plutonium isotope that was plutonium-235. But at the same time, he had said, well, it's such an unstable element that it would pick up an additional neutron and degenerate into plutonium-240. And that would increase the risk of something that is called pre-detonation. It would explode on its own, so to speak. And so that way, before the so-called bullet and the target mechanism would come together. So that almost ruled out the so-called gun-type mechanism that was feasible for uranium bomb. And so this was their big issues. Subsequently, again, to their credit, another chemist who was an Italian immigrant named Emilio Sagre, it said, okay, well, if that cosmic rays would infiltrate and were causing a difficulty with the neutron influx of the plutonium mechanism, the radioactive mechanism. So if we could keep that in control, we'll be able to increase the timing. Okay, now I showed this picture, but I just thought it was impressive to see how women who are the unsung heroes were manning all these big calutron operators, which was just to refresh your memory. That was the memory of the Lorenz's electromagnetic separation method that was used in Tennessee, and their job was to keep the needle right in place. So these were just to refine uranium ore into fissionable material. And so many of these women were not told anything. Some of them did not realize until the public tour was given 50 years later. I don't know if somebody has I think somebody has a question in chat, which I cannot read.
It was a comment from John, I believe.
Oh, okay. Yeah, John, please. I think I can't see if I can open it. Okay. Oh yes, we talked about it. Oh no, sorry, this is a different opera that you talked about, Dr. Atomic. Okay, now because that is different than the Copenhagen. Yeah. No, I did not know about this one. So, okay, thanks, John. So I think, yeah, John has commented about the Oppenheimer's personal life opera type thing. So, no, thank you. I wasn't aware of it. Yeah. Okay, I think hopefully it's in English, because most of the operas and it's not in Sanskrit.
Yes,
okay.
Yes, it is in English, but it has Sanskrit in it.
Okay. Oh yeah, I think you had sent me that out. Yeah, I think I remember you said this type
and
thing.
it quotes poetry. It's really an interesting opera. His wife Kitty was an alcoholic.
Yes, yeah,
and that's part of the opera too.
And yeah, and his girlfriend was communist, so obviously, so that was, and that's why he was being, that the FBI had a big file on him, and I think in the last slice out too, as to how he was chased, type thing, and
he lost his clearance, and he was very upset about that, but he lost his clearance in the 50s.
Yeah, I'll talk about it in the last session. I have several slides about Edward Teller. That's why I think, but as long as you brought it up, I'll tell you that if you had to pick a most hated physicist of all, amongst all the people who worked in Manhattan Project, that has got to be Edward Teller, because Edward Teller gave evidence against Oppenheimer at the McCarthy hearings when he was being, persecuted. Said. So Edward Teller was said, if I had known what I know about Dr. Oppenheimer, I would not have selected him. So obviously he became a persona non grata amongst all the Manhattan scientists, So just to, because I was going to talk about it in the last session, because when we wind down after the Hiroshima thing as to how Oppenheimer, and it ruined the man because he just lost his health and, he's lost his security clearance. But that's, that's for the last session, that we'll talk about. Okay, so this is a picture about how compartmentalized actually worked in the Manhattan Project and the operators had no clue as to what they were doing, and this was some of the housing that was temporarily housing that was built up, and this is, and to think just from total wilderness, this is what they came up with. This is the inside of the reactors, the main control room of the uranium enrichment project, as to how within less than 1 year, they were able to come up with the whole gigantic effort of various nuclear plants. I mean, it's just mind-boggling when you see the scale of as to the amount of redundancy that was done, because there were several methods that we talked about in the running, and all of them were tried. Groves was going to make sure that there was no failure at the end, so to speak. And even the Hanford reactor just was built in a record time and began functioning as early as September of 44 from acquiring land and evacuating people. And it just initially it was a bit slow because of something which I'm not going to get into the chemistry of, which something called xenon poisoning, which took place with processing. But eventually they were able to overcome the problem, and as early as February of 1945, they were able to ship the plutonium from Washington State to Los Alamos. And gradually, initially they were relying on planes and trains, but then they gradually switched to military trucks. And the supply increased rather quickly, that by May, they were fairly confident that the supply had increased fivefold, and they were able to come up with enough material for a second device, plutonium. And this again shows from nothing as to how quickly, by 1945, this was a gigantic, only one complex of 44 acres at Oak Ridge, Tennessee, that came up. So it was it's a phenomenal success that was carried out. And again, this is just a scene from Groves after the end of war. So okay, I think the one picture that I overlooked. Okay, this shows the picture of the shift change at the Y2 uranium enrichment plant. So all these women, you can see that, and obviously you can see that. Now this is I'll talk a little bit more about it if time permits, as to how segregated Oak Ridge was at that time. And I just found a nice 70-page PDF of African Americans during the Manhattan Project, type of thing. So hopefully I'll be able to include a couple of slides, type of thing, as to how segregated the project areas were, type things. And a lot of these women, with the shift working and make a CEW count, which was, for whatever reasons, I don't understand, I haven't looked it up as to it. It stands for Clinton Engineering Works, and I think it was a few years before Bill Clinton was born, I think. Now, another chapter that we need to talk briefly about was that there were, as we talked about, Niels Bohr, who was the father of quantum physics that we talked about in first class. And now he was, by that time, Denmark was already occupied, and he managed to escape to Sweden in a hurry, because Sweden was still neutral. And at that time, he was such a valuable asset that the Brits had sent in a plane that even from Sweden to bring him back to UK. So they had sent a special plane for him for Sweden. And now Niels, the picture doesn't do his justice, but he was a large man with a big head, and the helmet did not fit his head in this plane, which was flying at high altitude. And the famous scientist, he almost fainted with the lack of oxygen on the plane. So, but finally he regained consciousness when they were able to land in UK. And Niels Bohr then made a trip to the United States in '43, and I talked about as to why I had, if you may recall, in the first class, I had a slide about how they announced the famous scientist visits New York. So much for secrecy. That was the title of the slide. Now, at this time, Niels Bohr was a polymath, to put it mildly, and he was already thinking ahead about, he had toured the United States, and he was given a special tour of the Manhattan Project, and he had made some valuable suggestions about the project at that time. But he was thinking ahead of as to what this weapon could do and what the future of warfare will be. So he had made several attempts that, yes, that this is such a destructive power that we are generating, that this could not be monopolized. And he had laid out some feelers through his connection with the Supreme Court Justice Felix Frankfurter, who he had known right after First World War from their Oxford days, and he had managed to write a letter as to how there should be some type of understanding between major powers, including not just United States and Britain, but also Soviet Union. And obviously by that time France was occupied, so they were not too much of a factor as to so to collaborate in some way. And finally he was granted a meeting with FDR, and FDR was quite receptive to this concept that yes, that this should be considered, and he looked at it favorably. But unfortunately, the old Victorian Prime Minister Winston uh, uh, wrote two words to the letter that was the idea that was proposed by Niels Bohr about collaboration with the Russian. Collaborate? No way, or absolutely not. That was his response. And then Roosevelt again had encouraged Niels Bohr to even, when he went back to Britain, to meet with Winston Churchill. And Winston Churchill absolutely just gave a monologue to Niels Bohr and absolutely didn't give him a time of the day, so to speak. And Bohr's reaction was, we did not speak the same language. He disagreed with the idea of openness and strongly felt that the atomic weapon should be kept under control of Anglo-American alliance. And so one can say that there was an opportunity that was lost and might have written the course of history totally differently if, and obviously by that time, towards the end, FDR had died, and Truman had a different set of ideas. And so it was, and so much so that Churchill was really totally against this, because Niels Bohr had connection even with the Russians, because at that time the European science community worked in close collaboration, and the Russian atomic scientists, which I'll have several things to talk about later on, were in favor of that. Well, he would be welcome to Soviet Union and work there, or even listen to his ideas. So they were receptive to the concept. And based on that, Churchill was almost paranoid that Professor Bohr should be kept in check, and he may be a spy for the Russians. So instead of being the so-called ambassador of goodwill, Bohr was maligned by Winston. And Roosevelt had chuckled at it. And again, his death changed the course of history, to put it mildly. Now, again, I think hopefully you guys can see the slide, that they were working with some pretty serious materials. So it wasn't without this risk that, in spite of precautions that were taken by the scientists on board, that there were a few accidents, which were hidden from the public and news media in general, that a couple of scientists who were working with experimentation with plutonium, that while working closely, a minor mishap occurred, and one or two people had died due to radiation poisoning. And Groves made sure that this was not made public. And this is in memory of a guy named Harry, mispronounced it, Dagian, who died in 1945. And subsequently, another person also died of radiation poisoning. And later reports were given in the medical journal that came out in, I don't know, it was in JAMA or Annals of Medicine, 1952, about the three-dimensional burn that took place, and from the plutonium exposure. So it is just one of shows that way before Chernobyl and 3 Mile Island, the radiation, and at that time the military people were rather clueless about the potential that was there for toxicity. and we'll talk more about it, and or I can just mention that so much so that General Groves, after dropping the bomb uh, on Hiroshima, was in favor of sending out more air raids right after that, with little regard to the radiation that would be leaking in the air after dropping the first bomb. So it was really downplayed, or they were, at least the military was rather clueless about it, so to speak. And 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 again, so this was one of the first fatalities about his screwdriver had completely slipped, and the radiation had crossed, in spite of all the precautions that were being taken, that was one of the earliest steps that took place. Again, some secrecy was, and in spite of that, close to 120,000 people who worked, but the to their credit must be said that the compartmentalized policy did work, and so much so that the vice president had never heard of the Manhattan Project. But it must be said that he was the vice president only for about 80 days, and he was not the first choice, as the historians, history buffs would know very much, of FDR during his last election. Okay, all right, and any questions or comments so far? Okay, and this is obviously well-known fact that Harry, the president, is dead. Okay, and then Eleanor Roosevelt's statement was that now it is your problem, and you're the one who is in trouble now, so to speak. So this was, and he had met FDR only twice, and FDR died on April 4, 1945, and these are the various things. And his big important person who plays a big role is from left to right was Henry Stimson, okay, and Frances Perkins, she was the woman right here, Secretary of Labor. Henry Stimson, he had served about 4 presidents, and he was the Secretary of War at that time. Then various other people who are don't figure large into the picture type of thing, but Henry Stimson is the one, and Bess Truman, is taking the oath. Okay, so and so Truman had to catch up with the information rather very quickly as to the potential lethal and weapon that the United States was working on, and he wanted in a brief summary. Even the abridged summary was almost 50 page long, and Groves and Stimson gave him a rather quick first-hand instruction as to what. Now, by that time, the war was coming to the end, and these are at least the famous picture of the war that you may be familiar with the bottom one. I should try to monitor the chat, okay. Okay. Okay, yeah. So yeah, I think okay, if Kevin has any special this thing, then just jump right in. I think Kevin's comment was that he has visited K25 and Y12, and when he as a part of his business this thing. So yeah, I think it's a bit of fun this thing. I don't know if regular people are allowed the tour or not. Probably not. Okay.
Yeah, Bharat, the only reason I was allowed in was because I had a previous top secret crypto clearance, and even so, when you visited, I went to both K25 and Y12. You would have to wear kind of a helmet with panels on the side, and you had to look straight ahead and just walk down this the aisleway that was black and yellow stripes, and you had an armed guard in front of you and an armed guard in back of you. So even in the 80s, they were still pretty serious about the security there.
It reminds me of that movie starring Mike about the guy who cracks into the Dakota missile thing, type of thing, and just sets up the code. It was a 1980s movie. I forget the title, type thing. So he's a 14-year-old kid who cracks into the code, you know, that thing, well, but anyway, we're digressing. But so
It's
this
called
was,
War Games.
War Games. Yeah, okay, that was the one. Yeah, so that's what I was thinking about. So yeah, it was fun movie type of thing as to how he has to look straight ahead. He gets into the tour type thing, and ultimately, finally the chess. Oh, wouldn't you like to play a nice game of chess? So I remember that. I think it was the '80s movie. Thanks for refreshing my memory. So, and again, this is the famous picture from the other side of the pond and the headline. So the war had ended, but at the same time, you can just say that the army had, now by this time, I think I should jump ahead type of thing, that the person who wanted to be the vice president candidate for FDR was a guy named Burns. And for whatever political reasons, Truman was chosen. And Truman rewarded Burns by making him Secretary of State. And he was a Southerner. And I'll have a slide about him later on type of thing. But again, so they had already spent $2 billion on it. So they wanted to make sure this was going to be used, I think on the Japanese side. So, and there'll be a lot more to say about how the target was chosen and how the decision making took place. The scientists versus the politicians. Okay, now just to get a word out of the way about the first bomb, which was the uranium device, and that was a standard so-called gun type device, which was I should have moved my title to the middle, sorry. Okay, yeah, there it goes. Working on the slide type of thing. So I'm doing my slideshow slightly differently, so it's easy to do it. So it should have looks better. Okay, so this was a gun type design. Basically the so-called target and the bullet, it slams into it and causes the chain reaction. And it is the conventional explosive, which is the good old TNT, aka Alfred Nobel's invention, the 2,000 pounds. It's a blockbuster, so it explodes the device. And we talked about the gun type mechanism. So it was, but it worked like a charm for the uranium device. Did not work for plutonium, as we'll talk more about it. Okay, and because of the spontaneous neutron emission, it was fizzle out, so to speak. Okay, so that was that big problem that they had to deal with, and it would cause a premature chain reaction, lasting for just like 100 microsecond. And this problem, they discovered it in 1944. So the theoretical division of physicists had a whale of a time solving that problem as to what type of exploding mechanism they ought to come up with. And various giant brains had to work on this, starting from, okay, again, the chemists, it came to one chemist who was reluctant to work was a guy with name which is hard to pronounce, Kawasaki. Okay, and he was an expert in explosive chemistry, and based on, and obviously various other people had come up with the idea, and people who were working on something called implosion device for plutonium bomb. And they struggled with this for several months. And this is the idea of implosion, is to create a shock wave, and which would compress the core of the plutonium, and so that it would trigger, to avoid a so-called dud explosive. And so it took several brains to work with, including the famous polymath von Neumann, who was a mathematician and a physicist and a computer pioneering computing scientist from Princeton. They had come up with the idea of so-called implosion device as to how the shock waves would not just, the initial unit, they were thinking about the shock wave would explode outwards, but based on reactions, it create a lot of turbulence inside the device, and it did not work. So von Neumann had come up with the idea of implosion, means that the shock wave would go inside and compress the plutonium core. And so this was one of the mechanisms that took them several months. Okay, and okay. And it just, because it is complex enough, I think it's just best shown.
The implosion design looked like a soccer ball on the outside with 32 lenses fitted to form a sphere. The lenses are made of a mixture of explosives and surround a baseball-sized core of plutonium. As physics professor Bruce Cameron Reed explains, detonating all the lenses at exactly the same time was crucial to produce an effective explosion.
Consider a spherical lump of plutonium, about the size of a softball sitting in my hand, and to trigger the nuclear explosion, this has to be compressed to a higher density. And so then the issue becomes, how do you compress a metal maybe to half of its initial volume? This requires an enormous amount of pressure, and the technique they developed for achieving this was to essentially wrap it in.
I'm sorry, I clicked the wrong button.
The implosion
has to be compressed to a higher density. And so then the issue becomes, how do you compress a metal maybe to half of its initial volume? This requires an enormous amount of pressure, and the technique they developed for achieving this was to essentially wrap it in segments of explosives in a three-dimensional assembly. Think of sort of pyramid-like chunks of explosives that would fit together like a three-dimensional jigsaw puzzle, which when detonated would blow inward to crush this thing. And given the speed of the explosive, they all had to trigger within a microsecond. There were 32 segments surrounding that core altogether. And if the implosion is, say, a little off-centered, the core might shoot out one side, and you get a much less efficient nuclear explosion.
If any of the explosives lens charges were misfired by even a microsecond, then the bomb could be a dud.
Okay, so you can see the problem. So it was, and they had to cast this explosive. Now, I don't know why they call it lenses. It just blew my mind. It took me a long time to figure out that there's nothing to do with a lens, but it's just a bunch of explosive, so which is highly explosive material called barytol, which is a mixture of barium and TNT. And that had to be cast inside various pyramid-shaped pieces. And the geometry and the fluid mechanics had to be worked out. So it was a challenge, to put it mildly. And for those of you who really want to know about it, this is the extremely complex picture. You can see how it's not for the faint-hearted, some of the chemistry that is involved. And these are the outer layer of explosive, inner layer of explosive, various materials, and the big kahuna is right there, the H, which is the plutonium-239, and various lining, and the initiator, that the first or isotope that triggers the first neutrons that enter, are based on polonium, which was AKA discovery of Marie Curie, and initiator, so to speak. So this is, an extremely complex device, and it took them several months to get it together. And to their credit, and even until the last minute, for the test device, they were not sure as to people. And some of the test runs that were done didn't turn out too well, and people were blaming this guy who was going to be the bad boy who failed the device, George Kistiakowsky. But again, as we'll see, and this brings us to the big part of today's talk.
Excuse me, Bharat, Bill Saffer has a question.
Oh, sure, please go ahead, Bill. Yeah.
Given literally the explosive nature of this device, how did they actually do the experimentation? I mean, in a sense, did they figure out all of the schematics, conceptually, and knew it would work? Or did they do some trial and error type experimentation?
But they had that smaller material, and they were able to do controlled laboratory experiments. A lot of them was theoretical work. Yeah, a lot of, and then they did the testing with a regular and they had a small amount, so they were able to do some of the lab experiments with very tiny amount type of thing, about to control, it's like a microgram or milligram type of device, so those were experiments where they were like close to about 2,400 experiments that were carried out, so to speak, in the laboratory setting, so they had, and I think for the sake of time, I didn't put, but there was like a huge amount of laboratory that was still there under Los Alamos, and so that with the tiny amount, and they were able to extrapolate mathematically some of the data. And for the Trinity bomb, they actually did the experiment with actual regular TNT. They took almost like 100 tons of TNT and did the explosion of dropping the bomb. So I'm just getting to that right now, so to speak. So they did both micro experiments as well as, with I think obviously they didn't have enough plutonium to do a real experiment, but they had a tiny amount. As the experiments became available, they were able to do, says yeah, and a lot of that was done theoretically, but they were able to do it on a very micro scale, some of the experiments that were done. So hopefully, that gives you some of this thing. So there was both theoretical as well as practical type thing. So there were two divisions, the theoretical divisions and the experimental division. So they worked parallelly because, they had a huge manpower and some people who are good with the experimental work, some people who worked great with theoretical division. So each division was staffed by close to more than 50 or 60 people. So it was, I think so. Those are some of the things, that they did have some firsthand thing, and a lot of that was, theoretical, but there was some practical this thing also, because they just didn't have enough material to do the test. So that's why this test that comes up, type of thing. So again, until the last minute, they were not sure as to how this thing would come around, so to speak. And one other thing that you'll get a kick out of it, which I may just jump into it, because with the test that was done, at the Trinity site, in New Mexico, at that time there were some people had actually legit concern that they would set the atmosphere on fire because of the explosion. And the first person that I talked about, Hans Bethe, he had done theoretically, because he was also a cosmologist, physicist. So he had done calculations that there is no way we're going to set up the atmosphere on fire. Okay, because otherwise there was real fear that this nuclear explosion could set atmosphere on fire. We could blow up the world. So there were real fears, but it was amazing the intellectual power that was there behind this thing. So it just, the more you read about it, it just blows your mind as to what what an intellectual tour de force for humanity, just to okay. So okay, and so this was the site that was selected was by a physicist as well as the military in White Sands, New Mexico, close to Alamogordo, and they wanted a huge area of site, Lakers, and they selected this was appropriate site and decided to do the testing of the plutonium, because uranium device they already knew it's going to work, so they did not have to test it. They were ready to ship it out to the Pacifics. Okay, and this was the amount that was done. Was, you can just see that how one person is able to carry the amount of core, and under lead cover, the loading of plutonium into the, and for secrecy they use the word gadget. Okay, and this was why the name Trinity was chosen. I think it was nothing. Wasn't quite everybody just thought it was the biblical association, but Oppenheimer, the true polymath, was saying that something special was happening in New Mexico. There's a poem by the English poet John Donne, written before his death, which I know I love. And you can read the poem by itself, and I'm not going to recite this thing, so that would be. And so this was the poem that inspired him. That still does not make a Trinity, and the better known as devotional poem, Batter My Heart, Great Precision Goes. So this intense nuclear explosion would transform sand into glass. And that literally did happen. Okay. And so this was the final device that was exploded. Now I have several more slides. And this was the first and only color photograph of the Trinity explosion that was done, because they had varieties of color, early days of color cameras, but none of them worked except by one physicist who went and took another shot after the explosion. And this is just to show that how Oppenheimer was a polymath. This is his quote from the Hindu epic poem, the Bhagavad Gita in Sanskrit.
He knew the world would not be the same. Few people laughed. Few people cried. Most people were silent. I remembered the line from the Hindu scripture, the Bhagavad Gita. Vishnu is trying to persuade the prince that he should do his duty, and to impress him takes on his multi-armed form and says, "Now I am become death, the destroyer of worlds." I suppose we all thought that one way or another.
Okay, now I think before we take a break, I think we have about 9 minutes, so I shall show the 5-minute video clip that would.
The very first bomb was called the Gadget. After 3 years and $2 billion, this is it. A 6-foot sphere filled with batteries, electronics, explosives, covered with cables to set it off and measure what happens. At its center, a grapefruit-sized ball of plutonium, the core. If this thing works, the world will never be the same. Everything comes down to a test in the New Mexico desert, code-named Trinity. It's July 1945. They've been preparing for months, putting in roads, shelters, and bunkers. Miles of cable. It's the biggest science experiment in history. If it works, they'll set off the world's first atomic explosion. No one has any idea what that will be like. They need to measure, record, photograph everything. Radiation levels, shock waves, temperatures, all unknown. All must be documented. Thousands of miles away in Potsdam, Germany, President Harry Truman is negotiating with Stalin. Does he have an atomic card in his hand? It all depends on the Trinity test. Back in New Mexico, George Kistiakowsky has discovered a problem.
It looked as if the bomb might be a dud. Since they had poured the explosive and it was hot when it was poured, there was the possibility there would be bubbles in there. So Kistiakowsky decided he had to fill those bubbles with liquid explosive.
Now Kistiakowsky must drill holes in the explosive and carefully fill each bubble. The outcome of the test depends on his fix, and there's no way to know if it will work.
There was a test on July 14th, a full-up explosive test, that went really bad, which then made him worry even a little bit more.
They are out of time. All they can do is press on and hope. They'll hoist the bomb to the top of a 100-foot steel tower. They pile mattresses under it, just in case. Thousands of people, years of work, are on the line. The last crucial piece, the grapefruit-sized plutonium core, a $350 million box, is delivered by car from Los Alamos. In Potsdam, Truman waits. The test is scheduled for tonight.
It begins to rain. We're going to have to postpone this thing. So there's great nervousness.
Most everybody really had a knot in their gut about all the electronic connections and there's a zillion things could go wrong.
The weather looks bad, but Groves refuses to give in.
And Groves becomes his own weatherman here and decides, we're going to have this test at 5:30. It looks as though it might clear just enough to get the test in.
Dawn was just beginning to break. We heard the countdown.
10 seconds.
It's July 16th, 1945. 3 years, hundreds of thousands of people, the futures of Groves and Oppenheimer.
Their careers involved. There's $2 billion spent. 7.
Unproven science, a president waiting, a chance to end the worst war in history.
3.
Will it work? The world will never be the same. No one who was there will ever forget it.
Couldn't believe that I would see it when I had my eyes closed.
It was the most incredible sight I've ever seen in my life. So it was brilliant white yellow to start with, and developed reds and orange and purple and blue.
I was just standing there with my mouth open.
Engineer Jack Abbey has brought his camera.
I snapped the shutter wide open.
Jack Abbey's picture is the only properly exposed color still photo from that night.
Okay, I think after this, we should probably take a 5-minute break, and I'll get a sip of water and stick around for any questions or comments. Okay, I think it's 10:57, and we'll see you in about 5-6 minutes. So I think, we just talked about now. I think I'm not going to torture you by trying to read the Sanskrit, because my Sanskrit is very rudimentary, because I took it only a couple of years. So I'm not going to try to pronounce the Oppenheimer quote, type of thing, because obviously he was much better educated than I ever shall be. Okay, and this is, so finally, Truman did get the message about the success, and so he received the coded message type of thing. So he was, and again, obviously that, and he, interesting, the piece of history that he was towards Stalin, and rather minimal words, as we have developed a lethal weapon, such as some very, he played in a casual statement, at the Potsdam conference, but Stalin was nonplussed, said, hopefully you'll be able to use it against the Japanese, because by that time the war had ended. So obviously he didn't exactly seem surprised. And that just ties in with the question that you had as to, because he already knew as to what they were up to. Okay. Yeah. Yeah, right. I think, we talked about the Paul Farmer's book, Kevin said a comment about it. So I think, yeah, I think it's a thought, I'll give that a thought, because I'm just reading more about the pandemics right now. So I think I may be brave enough to do that. Okay. And these are some of the quotes that are about the atom bomb that, and this one was, the first quote is from the physicist in UK who came to give advice, James Chadwick, who discovered the neutron, that as early as 1941, he realized that bomb was not only possible, it was inevitable. The second reason is by a British diplomat. Okay, Allies won the war because our German scientists, so that's about as cynical a statement, our German scientists were better than their German scientists. And the third statement is by the Italian experimental physicist, is Enrico Fermi, because a lot of physicists, by that time they had crisis of conscience that whether we are going to destroy humanity. Don't bother with your scruples. After all, it's all a so-called physics. So he just enjoyed the theoretical ride and the experimental ride rather than, okay. And the fourth is, again, Admiral Halsey, total destruction of the world. So these are various people had different sorts of reactions to this thing. Okay, just to show you a picture, this is the aftermath of the first explosion. Tapping at the glass, and the asphalt actually turned into glass, basically. So that, okay. And this is, I just thought this would be an interesting thing to show about, we are
inside science.
It was here in the middle of the desert that is now the U.S. Army White Sands Missile Range in New Mexico, where the world's first atomic bomb was tested and exploded on July 16, 1945. At the time, the remote government-owned land provided safety and secrecy for the test, codenamed Trinity. Now, the test site is a national tourist attraction, open to the public just 2 days a year, normally in April and October. There are not many artifacts to look at, but for history buffs or anyone interested in seeing where the start of the atomic age took place, visitors can walk around the site of the explosion and go inside the McDonald Ranch House where the plutonium core of the bomb was assembled.
The ranch house is part of the open house to this day. You can go inside and you can see the room where they did the assembly of the core. And one of the things that's kind of cool, I think, is when you go up and you can look on the window frames and see the staples that they had put into the walls to hold up the plastic covering up the windows to keep dust from getting into the room.
Although the site is essentially in the middle of nowhere, visitors still come from all over to see a little part of history.
The response that we get from visitors is as diverse as the visitors themselves. Some of them are in awe of being at the place where this occurred. Some of them look on with a sort of horror, recognizing what this weapon represents. Others are disappointed because there's not really much there. There's an obelisk and a very shallow, large crater and an old ranch house, and that's about it.
And sometimes they get a one-of-a-kind visitor.
One of the memorable visitors that we had one year was Jack Abey. He was a soldier who worked on the project, and he is the only person to take a color photograph of the test. Now, there were color cameras set up for the test,
okay. But I already mentioned that earlier, so I think you already know the point. So this is like, I should have trimmed it out, sorry. Okay, and again, we just talked about, so this is, and there are some more quotes about Oppenheimer was technically sweet, I was arguing about the use later. Now, the Admiral Halsey, went on further to say, scientists had a toy and wanted to try it out. The Ike said it was depressed, unnecessary, and he quoted the famous word, military-industrial complex type of thing. So, and at the same time, so, and obviously, the gut feeling was we had spent way too much money on it. We better use it, and obviously the people who are the hawks in the administration says, okay, well, this is our chance for world domination and monopoly type of thing. And again, by this time, the Alsos mission and the FBI had some idea about the Russian infiltration. And again, so that was already coming out. Okay, so now earlier one of you asked about the question, the spies. And so this is an interesting chapter type of thing about the spies versus spies. And again, it wasn't all from Russia with love, as James Bond would like us to know, but it was Russia with fear. So people still had fear. Now, in the first slide, we talked about Operation Alsos, which was already taking place, about seeing what the Germans were up to, because in 1943, the fear was very palpable, in spite of the fact that the Brits already knew that the Germans were nowhere up the steam. But again, the paranoia between the Allies continued because the Americans didn't trust the Brits, and the Brits were not had information, but it was not believed. And so that was, again, the big things. And the people who were given assignment was a colonel from First World War named Boris Paczewski, who had shortened his name to Boris Pash, and a Jewish physicist who had immigrated named Samuel Goudsmit. And he had done his graduation in Holland and then migrated to University of Michigan. And he was assigned the task of working, to contribute, perhaps, and so he was assigned the type to, because he was polymath in various languages. So he was one of the physicists who was assigned with Operation Alsos that we talked about. And again, as even before, as soon as the Allied invasion, the Alsos team had special privileges to go to Europe and find out what exactly to get the material that the Germans had, what the Germans were up to. So they made various attempts in all the countries as the invasion was taking place, starting from Italy to France to finally Germany. And some of the information that they got was useful. For example, one of the Italian physicist scientists that they were able to capture, he was able to provide enough information about the air tunnel that led to the further development of jet engines and some of the trials that took place. When they went to France, they were able to talk with the Curies and see how much progress that the Germans had made in using the cyclotron that they had carried out. They were using it for research, because France had the first cyclotron operational in Europe. And then obviously last not but the least, they were able to travel to Germany as to see how much uranium core ore that the Germans had, and they were able to successfully capture several thousand tons of uranium ore that they had. And by that time, the Germans were, had moved their procession to further east, and a small town which was called Oranienburg. And there was a lot of processing of what they were doing it to build experimental reactor under the leadership of Werner Heisenberg, the boy genius who had won the Nobel Prize in his early 20s. And we had mentioned him earlier, type of thing. And so that town and it was one of the most heavily bombed town, because Groves wanted to make sure that they did not continue to work. So even before, as soon after the Allied invasion, that was already, so that was one of the most heavily bombed towns to destroy their facilities. So, and finally they had moved to almost to a small cave. And finally they learned that the German progress was on a ridiculously small scale. And when Samuel Gaudsmit saw what they were up to, he was almost flabbergasted as to see that, well, this was, US had almost, 50 times more of work that was being already done. By that time, he was aware of what was going on. So he wondered it, and he amused himself loudly that if we had spent more money on intelligence rather than the Germans had spent, so we would have been able to change our approach, that the laboratories were well equipped, but at the same time, compared to the United States, it was a small time stuff. Now, there was a big distinction that this is an interesting slide that the Altos unit, they were chasing a bunch of radioactive thorium that was missing, and one of the German scientists that was captured, and he was initially rather reluctant to see what was going on with that thorium as to what happened, and he tried to avoid answering the question. Turns out that a lot of radioactive thorium was sent to an industry because they were using it as part of the toothpaste. Because again, the radioactive, so this is one of the commercials it had nothing to do with the bomb. Okay. And so this was one of the commercials in, obviously, I won't read the German, but it was one of the radioactive, toothpaste. So it was one of the radium craze that continued. Interestingly, again, what are we doing with a wine bottle on this? Okay, again, so just Oppenheimer had once an idea that if the Germans were actually working on radioactive testing, the water would be radioactive. So take a sample from the river, when you get to the mainland Germany. And if the water is radioactive, yes, obviously we're working on it. So the Alsos mission guys, obviously they were, not exactly regular military. So they took the water sample and along with that, by that time they had sent, they sent a bottle of wine that they selected, said, okay, well, they sent it back, collected the samples, sent it back to Washington for testing type of thing. So, and again, now turns out that the water was not radioactive, but the wine was, okay, because of and it turns out because the reason why the wine was radioactive, because of the natural infiltration of the rays. So it was one of the wine bottles that was more radioactive. So they said, water not radioactive, but send more wine. Okay, so that was the message that the telegram that was sent out. Again, so just to say it, from Russia with love turned into Russia with fear. And these were the two giant main men who worked on the Russian project, So Igor Kurchatov, he was the father of the Russian atomic bomb, and he worked on he had written he was given right by Beria, the secret KGB agent, and Stalin, and he was given the assignment to develop the Russian bomb. And obviously he eventually was successful with a little help from the West. Okay, so he had worked, originally I'd mentioned earlier that the Russians were no slouch to by all means, said that independently they'd come up with the idea of concept. And later on, the man who's well known because he was a Nobel Prize Peace winner, was Andrei Sakharov, who's well known to a lot of us. Okay, now again, another person who, again, it was interesting to see as to how much collaboration was there between all over Europe. The guy named Peter Kapitska, who had worked with Ernest Rutherford, who I mentioned in the first class, and has worked at the Cavendish Lab, and knew Niels Bohr, as I mentioned earlier, and he invited Niels Bohr for collaboration. Okay, but obviously, so that didn't turn out to be the case. So, but it just shows the amount of collaboration, and collaboration was taking place. Okay. Now, again, we will to introduce the subject of the spy. In September, Truman received a letter from the Canadian Prime Minister about informing the secrets of were being transferred to Manhattan, were being briefed on a microfilm. And again, this is almost like cloak and dagger stuff you see in the movies. It was transferred in the cigarette project, and the code names that the Russians had were a guy named Dexter and Raymond. And Truman obviously was shocked to receive this letter and told to Henry Stimson, this requires action. And none other than Colonel Pash was given assignment. Okay, and this leads us into the main character, the person who was instrumental in giving the spies, was Klaus Fuchs, who was a German mathematician, physicist, and who was a devout communist. And he was, again, this ties in with the implosion device that we talked about, because the Brits offered to assist, and he was given a rather hasty clearance to work in the United States along with Pearls, and this was the pride of the British consignment that came to work on the Manhattan Project. And he was a son of a Lutheran minister. His brother was a strong influence. He was a brilliant mathematician, physicist, and it was anti-Nazi, and was was given continued contact with communist, and he was interned at the Isle of Man and later to Canada, and was released due to a valuable war effort. And he worked on the amount of uranium-235 with a guy named Pearls at the Two Bellows project, and the Brits, and again had contact as early as 1942 with MI5. Being MI5 gave him security clearance in spite of knowing that he was a notorious communist from infiltration from the Gestapo. It suspected him at that time. So that was like a drop ball by the Brits. Okay, and here, Okay, so he was the main character, and later on he was caught finally in 1950 and gave a full confession and was sent to prison for 14 years. Okay, and he also worked on the hydrogen bomb later on. Okay, and that more about that, you know, if you have time, we'll talk about the hydrogen bomb. Okay, and various other spies who were there. Okay, were Julius and Ethel Rosenberg, who were the master spy couple who were American citizens, and they were eventually convicted for spying on behalf of Soviet Union, and they provided not just atomic information, but also top secret information on radar, sonar, jet propulsion system, and so this was, and they were convicted and executed in 1953. Okay, some of the lesser well-known figures were guys named May, who was a British physicist who worked in Canada. He supplied U-35 information, and he was sent for 6.5 years of prison. Again, now these people were, you know, devout believers in communism, so they didn't just do it for money, and they actually believed in the system. And quite a few of them thought that the Russians were being allies, were being treated unfairly, and that was one of the reasons for giving information. Okay, another well-known couple were named husband and wife couple named Maurice and Lona Cohen, and they were, you know, they all worked along in collaboration and provided secret papers, and some very interesting story as to how clever Lona Cohen was, that she was traveling by a train, and the military police were investigating, okay, the train as for this thing, and she handed her purse, you know, okay, and obviously with the packet that was there, okay, and she just claimed, you know, there was feminine hygiene product, and obviously the soldiers, you know, were too embarrassed, so handed the packet right back to her, you know, type of thing. And so she was able to, you know, hoodwink, and she was a charming woman. And again, you know, so she was, again, conducted various, not just technical, scientific, and industrial espionage, was delivering documents all over, and was able to charm her way to various sailors who came from South America and Europe, and so she was able to avoid detection by, you know, by her charm and her cleverness. Okay, on the British side, you know, the people who were well known were the so-called, let's move on one further, the so-called Cambridge Five, and those of you who are Anglophiles would know the most notorious one was Kim Philby, who was a double agent and was finally caught in 1963 and was managed to escape to Soviet Union. And the other people were well known, which are called Cambridge Five, were part of the MI5 things, you know. And I think it's worthwhile to see a video for the Cambridge Five.
The Cambridge spy ring was a ring of spies in the United Kingdom that passed information to the Soviet Union during World War II and was active from the 1930s until at least into the early 1950s. None were ever prosecuted for spying. The number and membership of the ring emerged slowly from the 1950s onwards. As far as the general public was concerned, this started with the sudden flight of Donald Maclean and Guy Burgess to the Soviet Union in 1951.
Sorry, I hit the wrong button.
Public was concerned, this started with the sudden flight of Donald Maclean and Guy Burgess to the Soviet Union in 1951. Suspicion immediately fell on Harold Kim Philby, but he did not defect until 1963. Anthony Blunt and John Cairncross, the last two of the group, confessed to British intelligence, but this remained a secret for many years, until 1979 for Anthony Blunt and 1990 for John Cairncross. In time, the Cambridge Four evolved to become the Cambridge Five. In the innermost circles of the KGB, they were supposedly dubbed as the Magnificent Five. The term Cambridge refers to the recruitment of the group during their education at the University of Cambridge in the 1930s. Thank you for watching. Like and
Okay, I think. Okay, let's. Okay, I think we'll continue with this thing. And now, how did all these people finally come to light? The United States had a secret. Were able to crack the Russian code because of Russian sloppiness, and this was a secret project that went on called the Venona Project, and this was really a breakthrough that the U.S. Secret Service and the Signal Corps had as to this was carried out and went on from during the war to and finally was made public in 1995 as to the significant project which continued from 43 to 80 and was declassified in 1995. And this exposed, and so Julius and Ethel Rosenberg were part of these team that were exposed based on this, and Alger Hiss and the guy named Dexter, who was part of the Treasury Department, and he worked with Morgenthau, who was the Secretary of Treasury. Okay, and so a lot of these people were exposed to this decoding project. Now, this decoding was carried out by the various unsung heroes, and a lot of them were women, starting with the early cryptologist was, before the computer days, was a guy named Jean Grable, and she was the little picture in this in middle, and various other ladies who were part of the Meredith Gardner, who's inside. They were code breakers who worked for FBI, and so this was one of the ways they were able to do. And again, during the trials, the prosecution did not want this to be known that they were able to they had cracked the Russian code, and so this was one of the reasons how Ethel Rosenberg. And now it is possible that Ethel was just was convicted because a lot of these Russian agents had code names, because as we talked about Dexter and various code names that were given, but Ethel Rosenberg was named in the project as Ethel, so perhaps she was convicted wrongly, and simply because the prosecution, they did not want to be aware that they had cracked the code. So maybe she was sacrificed, to keep the secret guarded, So that may have been one of the so these are the varieties of spies, and the main leader has got to be none other than Klaus Fuchs, who gave away the secrets, and so he was the kingpin who made the Russian work a lot more easy, because he gave the complete pictures of the implosion device and the plutonium extractions, and the Russians were able to actually send him the requests as to send this information. And I think so you have to say that this was the spy network that, and a couple of other ones, who were who were able to give so again, the varieties of Russian network was not only powerful. So the spies network that the Russians had between the four main powers, played a major role in giving information. Okay, now again, this we still have a lot going. It took us far less time to cover the spy agents, because I think I may have missed a couple of ones, who were family relations of the Rosenbergs and who gave evidence against the Rosenbergs, that the brother-in-law named Greenberg, and another chemist named Harry Gold, who also gave a lot of information. So Russians had, substantial network that was part of the espionage system. So Okay. And now, when it comes to selecting the target, because the politicians, including during the Truman administration, had decided that yes, and part of the reason was because the Japanese did not surrender that easily, even though they were outnumbered during the wars that was going on from various islands. Okay, that the Okinawa and other small islands during the chain of islands that were taken over, because most of the European theater, that if the enemy was outnumbered 1-4, that they would give up and become prisoners of war. And the Italians were notorious, obviously, for giving up, even though they were not quite that desperate situation. The ratio that was given during the German was, if they were outnumbered 1-4, then they would give up and become prisoners of war. During the Japanese theater, that the Japanese would fight to the last man, as to that they would never give up until they were almost incinerated by flamethrowers. So the U.S. Military had absolutely a fear that invading the mainland of Japan would involve huge number of casualties and deaths, and so they had a legitimate reason to use the atomic weapon, because they were not sure that the Japanese would give up that easily. And the people, and this again gets down into the various political considerations that were given, because the name that some of you may recognize, that General LeMay, who was the Air Force commander in the Pacific Theater, he had undertaken what is known as the firebombing of various cities of testing, because initially when they tried so-called precision bombing, that was successful in the European theater. That did not work too well, primarily because of the cloud cover over Japan. So he had undertaken the campaign of something called a firebombing of Japanese cities, and out of the 75 or 80 cities, as many as 60 were subjected to firebombing. And during one night of firebombing over Tokyo, they had managed to kill as many as 100,000 civilians, and huge number of buildings were destroyed. And so it was one of those campaigns that General LeMay undertook, so much so that even after the war, he himself had to say that, well, if he had lost the war, he would have been tried as a war criminal. Okay, so again, so the firebombing it caused huge amount of civilian loss. And by this time, so there was a committee that was appointed as to who favored the use of and part of it was a scientific committee of people who were selected during the Truman administration. And so this involved the three main scientists, Oppenheimer, Fermi, and Lawrence. And reluctantly, they had all agreed that yes, that the bomb should be used on Japan, because there was a huge number of scientists, a substantial number, who had written a letter favoring a demonstration. This is the Union of Concerned Scientists, and a poll that was carried out by, again, this goes back to the name that you recognize from the earlier thing, Leo Szilard, and was signed. And to the chagrin of General Groves, he had done a survey of the scientists, and as many as 70 out of 150 said they favored demonstration by Union of Concerned Scientists, and the signatures, they put their signature on this on the thing. The 70 out of 150 favored demonstration, okay, as opposed to now. And this, obviously, General Groves did not like this result, and he thought that, okay, well, how to discredit these people? They labeled them as Jewish, and they had no relatives. They'd gone soft, so to speak. So again, he managed to whitewash their opinions to a dramatic extent. And by this time, the three people who had reluctantly agreed that yes, and Oppenheimer, Fermi, and Lawrence, they served as scientific advisors, and the small committee that was appointed, they agreed with the use of dropping. Okay, and now we had underestimated the view from Moscow because we did not know what the Russians were, and the death of Roosevelt changed the equation. Okay, and Stalin, they already knew what the West was up to, and the people who are much more belligerent were Winston Churchill and the Secretary of State who was appointed, James Burns. And so that was one of the decisions to go ahead with dropping the big one. And this was the little boy, that was the first bomb that was dropped, 9,700 pounds, 10 feet long. Okay. The hollow cylinder configuration, traveling to set up chain reaction. Okay. And the reason that why they were named was the Thin Man was named after FDR. The Fat Man was named after Winston. Okay. And and subsequently, when the size was reduced, instead of Thin Man, it was called the Little Boy. Okay, after the gun design was reduced. So that's how the nicknames were given. Okay. So with the better shielding this thing, the size was reduced from 17 feet to 10 feet. So that's how it came to be called as Little Boy, how the acronyms were given. Okay. Okay. I think we may end up sooner than time because I think I'm going to run out of my number of slides that I had assigned for this thing because I'm going a lot faster. And then this was the reaction of the nuclear age, a blinding flash that was visible from 200 miles. Okay, mushroom cloud that reached 40,000 feet. Okay, and a half a mile crater. Okay, and this was okay. Another side thing it was interesting as to number of Operation Paperclip. That this was after the end of war, and this made an interesting reading. I kind of read this book a few years ago as to the number of intelligence agents, 1,600 scientists that were captured, including engineers from 1944 to 59, including the famous rocket scientist von Braun. And the Russians were not to be outdone. They moved about 2,200 scientists. And this is a YouTube video about the so-called Operation Paperclip. And Tom Lehrer, who I talked about earlier, is one of the mathematicians who had the popular songs. He had the song about Colonel von Braun. My job is to build the scientists. As long as the rockets go up, I don't care where they come down. Okay. Now, this was one of the controversies that was seen as to what target should be selected. And Hiroshima was left relatively untouched during the firebombing that took place. So that was one of the things. Another targets that were considered were Kyoto. Okay, was one of the consideration, and various other cities which the names may not be familiar with. That and now James Stinson, who was the Secretary of the War, and he again did not think, he was abhorred with the idea of bombing civilians, and he was well read with the Japanese history, and he vetoed selecting Kyoto as a target because Kyoto was the Japanese cultural center, had huge Buddhist temples and Shinto temples. So he eliminated Kyoto as one of the targets because it was surrounded by hills, but it was the cultural center of Japan. So he thought that was, he did not like the concept. So that was one of the reasons why Kyoto was not selected. Okay. as a target. Okay, let's see, what do we have next here? Okay, and this was the team that was selected for, okay, I'm sorry, that's, I should move this one so everything in the picture looks well centered. Okay, and this was the team starting with the well-known, well-recognized name, the Colonel Paul Tibbets. Now, along with before the Trinity was done, the team was assembled and they were practicing in Utah with various beat for 29. And he had several planes at his disposal and they were practicing. And the planes were specially modified to being somewhat lightweight for the practice run. And afterwards, he moved his whole squadron to the island, the Pacific Tinian Island. And Tibbets, and this was his team that was selected, and the various names that are of interesting importance. Okay, and okay, and then and by this time the first bomb was transported by SS Indianapolis to the Tinian Island, which was the starting point for the run to Hiroshima. And okay, after delivering successfully the bomb to the island, the cruiser SS Indianapolis was torpedoed by the Japanese submarines, and as many as I think anywhere between 5 to 800 sailors died, because of the SS Indianapolis when it was torpedoed. Okay, so this was, and this is Truman reads the report of dropping of the first bomb. Okay, and okay, and this was, I just thought this was an interesting contrast between Burns versus Stimson. Burns was the Secretary of State and born in 1882 and died lived to be almost 90. He was a Southern lawyer, and this always surprises me, as he was self-taught lawyer. As to in those days, no, he worked with some of the judges and was given license to practice law in North Carolina. And he was even though he was a Southern Democrat, he was an FDR supporter. He traveled with FDR to Yalta and was, as I mentioned earlier, he wanted to be selected as a vice presidential candidate, but FDR, for whatever political reason, chose Truman. And Truman relied on Burns and gave him a very plum job of Secretary of State. And again, when he was part of the committee of for the Manhattan Project, so he was well aware of the potential. And obviously, he was rather hawkish, and he wanted to use, think again as the bomb as managing Russia, and was part of the atomic diplomacy. On the other hand, a total contrast to Burns was Stimson, who was older. He was a Harvard-educated lawyer, and he served 4 presidents, starting from Hoover and FDR, and I think before that Hoover was Taft, okay, and Hoover, and obviously FDR during his several runs, and lastly Truman. And so he, again, was very instrumental in avoiding Kyoto as a target, as I mentioned a little while ago. Okay, and he was initially hesitant to support dropping the bomb without first warning. Okay, and he was much more aware and much more receptive to the idea for Niels Bohr about, the potential, and perhaps if FDR would have lived, maybe the whole thing would have been turned out differently. And but then finally, after realizing the Japanese reluctance to give up, he agreed with using atomic weapon on Japan.
Rod, Kevin has a comment.
Yeah, please go ahead.
Yeah, Burns was kind of an interesting guy. left school when after 7th grade, but he's one of the few people in our history, if maybe the only one, that served in all three branches of government. He was a member of the House as well as the Senate, and actually for a short period of time was a justice of the Supreme Court, in addition to serving as Secretary of State.
Yeah, right. Yeah, no, that's just amazes me when I read up his background. I said, wow, that is, far out as to how, how successful and influential he was, type of thing, and I think, it was part of the Southern Democrat establishment, so it just was an interesting character, to put it mildly, and he wielded a lot of influence, to say, yes, absolutely. No, thanks, but I wasn't aware of. And now again, I just thought it was interesting to put in a slide about Curtis LeMay. It was really absolutely was instrumental in firebombing of Japan. And I think, they may have killed as many as 200,000 civilians, when all done with, because as in simple one raid, they were able to, over Tokyo, there were as many as 100,000 civilian deaths. So the number varies anywhere depending upon who you read. And they incinerated an area of as much as 16 square miles. And this was one of the posters that he had sent, about the written in Japanese. It says, "Leave your cities." In the U.S., okay, your leaders are not going to be able to protect you. So, and then again, then he later on, he had a very illustrious career. That even after the war, he was the head of the Strategic Air Command post-war. And he was a vice president candidate for George Wallace when he ran for presidency. Okay, so again, he, again was instrumental in, and then I mentioned earlier as to he himself knew that what he was doing was not exactly quite humane, but large number of civilians were carried out. And last but not the least, post-war, Churchill lost the election. Okay, and part of the empire, and okay, okay, all right. I think we're. I think we'll probably should. Obviously, this is well known as to the Paul Tibbets plane. He named it after his mom. Okay, Enola. Okay, and so this was, Enola left the island of Tinian for Hiroshima. And again, within few hours, exploded, killing as many as anywhere between 80 to 140,000 people, and subsequently huge amount of radiation deaths that took place. Okay, and I think we'll talk more about the actual dropping during the next session. So I think I don't want to run over all of the Hiroshima thing, because so that I can do justice to that. So we probably will end a few minutes earlier than planned. Okay, and I'll go over some of these in more details next time around, type of thing, because this is a special subject altogether, and I want to make sure I can do justice to that. So let's end a little earlier than expected, perhaps, because I don't want to rush through some of these materials, and so hopefully I can cover them in a lot more details rather than then just gloss over it, because it's, obviously that's one of the big event that the class is all about. So let's stop this right now, a little earlier than expected, perhaps, and I'll stick around for a few minutes, and we can cover this in a little bit more detail, so I can put in some more interesting videos, type of thing. Okay, because I think some of these things I had timed it my talk in such a way so that I can, but I finished the Spies stuff earlier than I wanted to. So I think we'll just stop now rather than, and continue with the Hiroshima episode next time, along with some more interesting material about the post-war scene. Okay, and hopefully okay, so let's stop the recording, and then let's end a few minutes earlier than